Hello everyone. In this video, we'll solve a limit problem. The question is, what is the limit of the sequence 1 over n to the third times 1 squared plus 3 squared plus up to 2n minus 1 squared as n approaches infinity? How to solve this question? First, we need to simplify this sum. To do so, we need to use a formula. Here is a formula. That's 1 squared plus 2 squared plus k squared. Here k is a positive integer. Then just equal k times k plus 1 times 2k plus 1, then divided by 6. So now let's start with the sum. So here we have 1 squared plus 3 squared up to 2n minus 1 squared. So here, in this formula, that's the sum of squares of k consecutive integers. But in here, just dealing with odd integers. So we can now use this formula directly. So we can use a technique to go around it. So let's see. Because we want to use a formula, so we're going to do this. We are going to write as 1 squared plus 2 squared plus 3 squared up to 2n squared. Then compare these two groups. What terms here now in this group? That's just even number squared, like 2 squared, 4 squared, 2n squared. So that's why we just minus all the even number squared, just minus 2 squared plus 4 squared until 2n squared. Because here, that's from 1 squared until 2n squared, that is a sum of squares of 2n consecutive integers. So now we can use this formula. So here k equal 2n. So now let's use a formula for the first group. And here k is 2n. So we have 2n times 2n plus 1, then 2 times 2n plus 1, then divided by 6. Okay, so now let's see the second group. Because 2, 4, 2n, they are even numbers, so they have a common factor 2. After squared, they have a common factor 2 squared. So take a common factor 2 squared out. 2 squared out. Then here, the first term, that's 1 squared. The second term, that's a 2 squared until n squared. Then for this term, 2 and 6 cancel the common factor 2. So this is 1. So here, that's 3. Then copy here, that's just n times 2n plus 1. Then 2 times 2, that's 4n plus 1. Then divided by 3. Then for the second group, 2 squared, that's just 4. But here, that's 1 squared plus 2 squared until n squared. So that's the sum of squares of n consecutive integers. So we can use this formula. So for k equal n. So then just plug into the formula. Then here we have just n times n plus 1 times 2n plus 1. Then divided by 6. Then here, 4 and 6, they have common factor 2. So cancel the common factor. Here's a 2, here's a 3. Then in the next line, so we are going to take a common factor out, because so the first fraction here we have n. We have n here also. So we have a 2n plus 1 here. So we have 2n plus 1 here also. So that's why we take out the two common factors. So n times 2n plus 1. Then for the first group, only thing left, that's 4n plus 1. Then for the second group, we have 2 times n plus 1 left. So here we have 2n plus 1 left. Then the bottom, that's 3. Then simplify this part. So we have n times 2n plus 1. Then here 4n minus 2n, that's 2n. 1 minus 2, that's negative 1. Then divided by 3. For the top part, that's 2n plus 1 times 2n minus 1, that's 4n squared minus 1. Then times n, so here we have 4n to the third minus n, then divided by 3. So this is a simplified expression for the sum of squares of odd number integers. So here we are going to put this one back to the original sequence. So let's see. So this is the original question. So limit n go to infinity, 1 over n to the third. And here's a 1 squared plus 3 squared up to 2n minus 1 squared. So now we are going to use this simplified expression to replace this sum. And here we have limit n approaches infinity, 1 over n to the third. So then for the sum, use this simplified expression. That's 4n to the third minus n, then divided by 3. Then distribute the 1 over n to the third to the expression. Then we have here the first one, 4n to the third divided by 3 times n to the third. 3n to the third. Then minus the second one is n. The bottom, 3 times n to the third. 3n to the third. Then here, so n to the third and n to the third cancelled. Just 4 over 3. Then here we have n on top, we have n to the third on the bottom. So cancel out this one, here's 1. So the power 3 cancel out 1, so we still have 2. So then here we have, so the limit n go to infinity, 1 infinity. So here, this one just 4 over 3 for the first term. Then minus, so here's 1 over 3n squared. As n go to past infinity, the second term, 1 over 3n squared approaching 0. So then the whole expression inside the limit approaches 4 over 3. So that's why 4 over 3 is the answer for this limit. Thanks for watching. See you next time.